Okay, this video is going to take a look at week 5 homework. We're going to be going over the kinematics equations. We're going to identify the given, the unknown, and which equation should be used for the 5 problems that are on your homework. So if we go ahead and just jump into this, number 1, you can see that it says that you're starting from rest. So we're going to identify rest as our initial velocity. And then we know that the acceleration is 3 meters per second squared. That takes place for 10 seconds. So we've already identified our initial velocity, our acceleration, our time, and we're trying to find our final velocity right here. So final velocity, if that's what you're looking for, there's two choices for that. We can either go with this second equation, final velocity equals initial velocity plus acceleration times time, or you can go with this last equation here, vf squared equals vi squared plus 2 times a. This is a new variable for you. You've never seen it like this. Delta x is actually distance or displacement. So it's just another way of showing it, the change in your x-axis displacement. So just another way to see that, but it's basically your distance for all these problems. In this case, though, if we look at the variables we have a vi, an a, and a t that they've given us. So if you look at the difference between these two, this one uses time, whereas this last one does not. The fact that we have time in our word problem is going to suggest that we should probably go with this equation right here. So we're going to go ahead and write that one. Vf equals vi plus a times t. So that would be the equation you're going to want to use for number 1. On number 2, it says that you're starting from rest. Again, so we have an initial velocity there. The Roadrunner accelerates at 3 meters per second squared for 10 seconds. Wait a second. Did I have the same problem twice? It looks like I did. Okay, so the difference here between this one and the first problem is that here you're given an acceleration, the time again, but now we're looking for how far. Sorry, I was thinking of the exact same problem. So right here we're trying to find distance, and we know the initial velocity, we know the acceleration, and we know the time. And in this case, the best choice to go with, because we know the initial velocity, if you look at our three equations for distance, the first one uses an initial velocity and a final velocity, so we cannot use that equation. The third one over here uses final velocity times time. We do not have final velocity. So the only choice that we can go with is right here, this third equation. So it's going to be distance equals your initial velocity times time plus 1/2 acceleration times time squared. That should give you the distance that this Roadrunner traveled for. On number 3, a bullet starting from rest, again from rest, so we've got initial velocity. It accelerates at a very fast acceleration of 40,000 meters per second squared for 0.5 meters. And they want to know what the final velocity is going to be for this bullet. So in this case, you have an initial velocity, an acceleration, and a distance, and you're trying to find final velocity. And if you look at these two final velocity equations, this last one makes the most sense because it uses distance instead of time. And here you can see in this problem we have initial velocity, acceleration, and distance. So we'd be able to plug in our values into these spots for this last equation. So it's going to be Vf squared equals initial velocity squared plus 2 times a times the distance, 0.5 meters. Number 4, a car traveling at 20 meters per second applies its brakes and comes to a stop. This suggests that our initial velocity was 20 and our final velocity was 0 because we came to a stop. And it takes place for 4 seconds. They want to know the acceleration of the car. This is a very simple equation, right? Because we've done it before in our homeworks. It's just our final velocity minus our initial velocity divided by the change in time will give us our acceleration. Number 5, a car traveling at 20 meters per second applies its brakes and comes to a stop. So same situation. You have the initial velocity of 20. You have the final velocity of 0. and you have the time. But in this case, they want to know how far you go. And the best choice for this, given that we know the initial velocity, final velocity, and time, if you look at your equations, the best choice would be this first one right here, because we know the initial velocity, you know the final velocity, and you know the time. And you can find the distance. Again, delta x is distance, right? So your distance equals, and then it's going to be the 1/2 initial plus final times time. So this is going to be the basic setup for all these kinematics equations. Because there are multiple equations, you have to look at your problem and you have to decide based on what's given to you which equation will solve for what you need, and from there you just plug in and then you solve. So now that you know which equations to use and you know why we're picking them for each problem, you can go through on your homework and make sure that you finish the substitution step and the solution step. I do want you to still show the equation even though you're getting it here from the internet, because it's important that you reinforce which one you're using and start memorizing a little bit of when they're used and why. So if you have any questions, though, come to tutoring. We have tutoring on Mondays, Wednesdays, Thursdays, and Fridays in the morning from 8 to 4. And of course, you can ask any questions you may have during class.